This is Math 1, Unit 4, Section 1 or 4-1, solving systems by graphing. Well, what we want to talk about here is there's a lot of stuff here, and sometimes it's a little bit wordy, but when it says system, okay, that simply means more than one equation. So we're solving two equations simultaneously. And the reason it's called a system, or you need more than one equation, is there's more than one variable. You'll see when we get to example what I'm talking about. But for the next three objectives, we're going to be doing the exact same thing, but we're going to have different methods to get to that desired place. And what are we trying to do? In the next three, pretty much this whole unit is find the point, find the point at which the lines cross. Find the point at which the lines cross. That's what we're looking for. Okay? You can see it down here in their explanation, but it's an find the intersection point. That's what we're trying to do. And like I said, there's different ways to do this, and you can see from the title here, the first one we're going to learn how to do is by graphing. So I'm going to come down here to the got it, and I'm going to graph these. Okay, and so if I go ahead and do this, okay, I'll go ahead and kind of set my graph up here. Now there's a couple of things that make this challenging. One of which is you have to be really neat, because if you're not, you're probably not going to find the solution, even though you're kind of going through and doing the steps correctly. So we have to take our time and make sure that we really don't rush and make this sloppy. Okay. So if I take this first equation up here, the one on the top, and I say y equals 2x plus 4, well, my m in this case is 2 over 1, and my b is positive 4. So if I go ahead and graph that, I go 1, 2, 3, and 4, and remember, try to make a small dot to make you more accurate. And then from there, I have a slope of up 2 over 1. Okay? And then I'll go ahead and draw the line. Okay? Make it as accurate as I can. Okay? Alright, so now I'll take this other equation here and I'll say y equals x plus 2. And this has a slope of 1 over 1 and a b of positive 2. So I go to positive 2, I go up 1 and over 1. Okay. And I will graph this point, or this line, sorry. Now the question is, what is the solution? The solution is the point at which the lines cross or intersect. So if you look at my graph here, I just simply say, hey, they cross right there. That is the coordinate point, -2, 0. So the answer to this is -2, 0. I just solved a system of equations. Remember, system means more than one. There's two equations and two variables. Keep going here. Looking at question number 1, if I was you, I'd hit pause and try to graph these two by yourself and then just check your answers afterwards. But I'm going to go ahead and graph these. So set my graph up here. Alright. So this first one here, I'm going to graph that. I can think of that as plus 0. So I go up, I start at 0 and I go up 2 over 1. Okay, and I'll graph that. Okay, so it goes through right about like this. Okay. And then this one starts at positive 8. 1, 2, 3, 4, 5, 6, 7, and 8. This one goes down 2 over 1. Okay. I draw a line through that one, and then I look and see they cross right there, and that is the coordinate point over 2 and up 4. So the answer is 2, 4, and it has to be an x and a y because it's a point, it's a location on the graph. Looking at number 2 here. Go ahead and set this one up. Alright. And I'm going to cheat this one over just a bit here. We'll probably be okay. We'll just try it like this. Alright. So I'll start with this top one over here. I start at 7. 1, 2, 3, 4, 5, 6, and 7. And I go up 1 over 2. Okay. I kind of lost my place here. 1, 2, 3, 4, 6, and 7. Okay. And I'm going to go ahead and graph another point just to be a little bit more accurate. So I'm also going to go up 1 and 2 more again. So I kind of have 3 points to hit. It's going to make me a little bit more accurate here when I graph. Okay. And the other one I start at positive 3. 1, 2, 3. And I go up 3. 1, 2, 3, and over 2. I'm going to do it again. 1, 2, 3, and over 2. So you can kind of see where I'm at here. And there's my solution right there. And if that looks like it's over 1, 2, 3, and 4, and then up 9, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And there's my solution. We'll go ahead and skip problem 2. This method I don't think is very efficient, and we'll come up with a way to solve these a little bit later in a unit or section or two. Okay. So we're going to jump to problem number 3. And you can read through these shaded areas to give the definition. I'm kind of just giving you a quick version of this stuff, but it says, what is the solution to the solution of the system? Okay. And you can see here it's called systems with infinitely many solutions or no solutions. There's probably something weird is going to kind of happen here. So let's go through the same process and let's graph these. So if I look at this first one, okay. So I'm going to start at the top one, -3, 1, 2, and 3. I go down 1 over 1. I'm going to do that a couple of times so I get a little better looking line. Okay. And then this one is +5, 1, 2, 3, 4, and 5. Down 1 over 1, down 1 over 1. Okay. And I got this line. And if I look at it, remember I'm trying to find the spot in which they cross, and it doesn't look like it. If you remember back to chapter 3, these m's are the same. In other words, the slopes are the same. So if the slopes are the same, these two lines are parallel. So parallel lines do not cross. Okay? These are parallel. They don't cross. Okay? So the answer is no solution. They do not cross. Okay? So let's go ahead and take a look at the next one here. I'll go ahead and graph this top one. 1, 2, and 3. Up 3 over 1, up 3 over 1. Okay. Well, and then I look at the second equation in B and I realize it's not in slope-intercept form. So I can't find the y-intercept, or what we call the B. So I got to manipulate it a little bit. So I'm going to come over here and give myself a little bit of room. And I'm going to solve for y. And I get y equals 3x minus 3. Okay. If I start to graph this one, I get negative 3, up 3 over 1, up 3 over 1. And you might have realized here, it's actually the exact same equation. So I'm kind of putting a different set of arrows to show like one line on top of each other. So I actually just graphed the exact same line twice. So if the solution is defined as where the lines cross, well, they're on top of each other and they cross everywhere. So it's not one solution, there's actually an infinitely many solutions. There's actually infinitely many solutions. So this part C, so it says reasoning, is before graphing the equation, can you determine whether the system of equation exactly one solution, which we did in the earlier examples, they just cross someplace, infinitely many, like we did here in part B, or no solution, which we just did here in part A. And so you can actually just look at the equations and kind of tell some things. So for example, kind of just write this in kind of some blank sentences here, but if the slopes are different, there is one solution. They're going to cross one time. Okay. If the slopes are the same and the y-intercept is different, okay, there is no solution. Okay. And lastly, if the slopes and y-intercepts are the same, it is infinitely many solutions.